Vector Database Case Study with Spring Boot Introduction. A vector database case study with Spring Boot explains how to build a real-world AI-powered search or RAG system using Spring Boot and a vector database. Backend developers often learn this topic to build semantic search APIs, AI knowledge bases, document Q&A systems, chatbot memory, recommendation engines, intelligent support systems, enterprise RAG platforms, Spring Boot AI microservices. A common learning topic is how can Spring Boot developers use vector databases in real-world backend applications? This guide explains: check real-world problem, system requirements, vector database architecture, Spring Boot backend design, embedding generation, document chunking, vector storage, semantic search, RAG flow, PostgreSQL metadata, multi-tenancy, security, performance, deployment, best practices, interview questions. This is one of the best practical case studies for backend developers learning vector databases with Spring Boot. Simple definition. A vector database is a database that stores embeddings and finds similar data using similarity search. Spring Boot is a Java framework used to build backend APIs, microservices, and enterprise applications. Together, Spring Boot plus vector database equals AI-powered backend system. Example: how do I reset my password? Vector DB finds password reset document, login troubleshooting guide, account recovery FAQ. Spring Boot returns the most relevant answer. Case study: AI knowledge-based search system, problem statement. A company has thousands of documents. C. PDFs. C. Support articles. C. Technical guides. C. Product manuals. C. Policy documents. C. FAQ pages. C. Internal wiki pages. Users struggle to find the right information using normal keyword search. Example: user searches cannot access account, but document title says login recovery and password reset guide. Traditional search may miss this. The company wants a smart search system that understands meaning. Business requirement. The system should allow users to upload documents, search documents by meaning, ask questions, get relevant document sections, view source references, filter by category, support multiple organizations, protect private documents, scale for large document volume. Technical requirement. The backend system should support Spring Boot REST APIs, document upload, text extraction, document chunking, embedding generation, vector database storage, semantic search, metadata filtering, PostgreSQL metadata storage, JWT authentication, tenant-based authorization, async ingestion, using Kafka. High-level architecture: React frontend, Spring Boot API gateway, document service, embedding service, vector database, PostgreSQL metadata database. Extended architecture: user uploads document, Spring Boot upload API, store file in object storage, publish Kafka event, embedding worker, extract text, split into chunks, generate embeddings, store vectors, save metadata. Why use vector database? Traditional keyword search works like this. Search exact words. Vector search works like this. Search meaning. Example: query, car payment balance. Can match, auto loan remaining amount, vehicle finance outstanding balance, monthly installment payoff. This makes vector databases useful for check, support search, search, AI chatbots, internal documentation, product search, legal document search, resume matching, recommendation systems. Technology stack layer, technology backend. Spring Boot 3, language Java 17+, database PostgreSQL, vector store, pgvector, Qdrant, Pinecone, AI integration, Spring AI, messaging, Kafka, cache, Redis, file storage, S3, local storage, authentication, Spring Security, plus JWT, deployment, Docker plus Kubernetes, monitoring, Prometheus plus Grafana. Recommended vector database options. VectorDB Best 4. pgvector, simple PostgreSQL-based projects. Qdrant, fast open-source vector search. Pinecone, managed cloud vector DB. Weaviate, AI native search platform. Milvus, large-scale vector search. Chroma, local beginner RAG projects. For Spring Boot beginners, start with PostgreSQL plus pgvector. For production scale, use Qdrant, Pinecone, Weaviate, or Milvus case study flow. The system has two major flows. 1. Document ingestion flow. Upload document, extract text, split text into chunks, generate embeddings, store vectors, save metadata. Search flow. User enters query, generate query embedding, search vector database, apply metadata filters, return top matching chunks, show results to user. Step 1. Create Spring Boot project. Required dependencies. Check Spring Web. Check Spring Data JPA. Check PostgreSQL driver. Check Spring Security. Check Validation. Check Spring AI. Check Kafka. Check Actuator. Example Maven dependencies. Dependencies. A dependency, group ID, org.springframework.boot. Group ID, artifact ID, Spring Boot Starter Web, artifact ID. Dependency, group ID, org.springframework.boot. Group ID, artifact ID, Spring Boot Starter Data JPA, artifact ID. Dependency, group ID, org.postgresql, artifact ID, PostgreSQL, artifact ID. A dependency, group ID, org.springframework AI, group ID, artifact ID, Spring AI OpenAI Spring Boot Starter. End of dependencies. Step 2. Configure PostgreSQL with pgvector. Enable pgvector extension. Create extension, if not exists vector. Create document chunk table. Create table document chunks. ID UUID primary key. Document ID UUID not null. Tenant ID varchar 100 not null. Title varchar 255. Content text. Embedding vector 1536. Category varchar 100. Source URL text. Created at timestamp default. Current timestamp. Create vector index. Create index. Document chunks embedding IDX. On document chunks using HNSW. Embedding vector cosine ops. Step 3. Design database tables. Document table. Create table documents. ID UUID primary key. Tenant ID varchar 100 not null. File name varchar 255. File type varchar 50. Status varchar 50. Created at timestamp. Default current timestamp. Document chunk table. Create table document chunks. ID UUID primary key. Document ID UUID not null. Tenant ID varchar 100 not null. Chunk index int. Content text. Embedding vector 1536. Metadata JSON B. Created at timestamp. Default current timestamp. Entity classes document entity. At entity. At table name documents. Public class document entity. Add private UUID ID. Private string tenant IDI. Private string file name. Private string file type. Private string status. Private string created by. Private local datetime created at. Document chunk entity. At entity at table name document chunks. Public class document chunk entity. At id private UUID id. Private UUID document ID. Private string tenant ID. Private integer chunk index. Column definition equals text. Private string content. That column definition equals vector 1536. Private float embedding. Private local datetime created at. Note: some projects use native SQL for vector columns because JPA support can be limited. Step 5. Document upload API. Example endpoint. Post API documents upload. Controller. REST controller. At request mapping. API documents. Public class document controller. Private final document service, document service. Public document controller, document service, document service. This document service equals document service. At post mapping, upload, public document response, upload, at request param, multipart file, file. Return document service, dot upload, file. Service flow. Receive file, validate file, store file, create document record, publish ingestion event, return document ID. Step 6. Create document service, at service public class, document service. Private final document repository, document repository. Private final document event publisher, event publisher. Public document service, document repository, document repository, document event publisher, event publisher. This document repository equals document repository. This event publisher equals event publisher. Public document response, upload, multipart file, file. UUID document ID equals UUID.random UUID. Document entity document equals new document entity. Document set ID, document ID. Document set file name, file get original file name. Document set file type, file get content type. Document set status, processing. Document set created at, local datetime now. Document repository, dot, save, document. Event publisher, dot, publish document uploaded, document ID. Return new document response, document ID, processing. Event, example. Document ID, 8B5A9D2E, 4B4E, 4C7C, 9A5C, 1234568 Tenant ID, ORG101. File path, documents, policy.pdf. Kafka publisher. Add service, public class document event publisher. Private final Kafka template, string document uploaded event, Kafka template. Public document event publisher. Kafka template string document uploaded event, Kafka template. This Kafka template equals Kafka template. Public void publish document uploaded, UUID document ID. Document uploaded event event equals new document uploaded event, document ID. Kafka template.send document uploaded topic, event.
Why Kafka?
Check. Async processing, better scalability, retry support, avoid slow upload response, separates upload and embedding logic. Step 8. Consume Kafka event, add component, public class, document ingestion consumer. Private final document ingestion service, ingestion service. Public document ingestion consumer, document ingestion service, ingestion service. This ingestion service equals ingestion service. At Kafka listener, topics equals document uploaded topic. Public void consume, document uploaded event. Ingestion service dot process document, event document ID. Common tools. Apache Tika, PDF box, OCR tools for scanned PDFs, docx parsers. Service example. At service, public class, text extraction service. Public string extract text, path file path. Use Apache Tika or PDF box in real projects. Return extracted document text. Flow. PDF, docx, txt. Text extraction service. Plain text, step 10. Chunking means splitting large text into smaller, meaningful sections. Example. Full document. Chunk 1, Introduction. Chunk 2, Pricing. Chunk 3, Refund policy. Chunk 4, Contact support. Chunking service. At service, public class text chunking service. Public list string, chunk string text. Int, chunk size, equals 1000. List of string chunks equals new array list. 4, int, I equals 0. I equals text.length. I plus chunk size. Chunks add text.substring. I mathmin text.length. I plus chunk size. Return chunks. A. Better chunking should consider. Paragraphs, sentence boundaries, headings, overlap, token limits. Step 11. Generate embeddings. Embedding means converting text into vector numbers. Example: Spring Boot JWT Authentication Guide. Becomes 0.12, -0.34, 0.88. Embedding service. Service public class, embedding service. Private final embedding model, embedding model. Public embedding service, embedding model, embedding model. This embedding model equals embedding model. Public float, create embedding, string text. Embedding response equals embedding model.embed for response, list of text. Return response.getResults, get 0, get output.toArray. End. Step 12. Store vectors. Vector store repository using native SQL. Repository, public class, vector repository. Private, final, JDBC template, JDBC template. Public, vector repository, JDBC template, JDBC template. This.jdbc template equals JDBC template. Public void save chunk, UUID ID, UUID document ID, string tenant ID, int chunk index, string content, float embedding. String SQL equals insert into document chunks, ID, document ID, tenant ID, chunk index, content, embedding, values x, 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 vector, JDBC template.update, SQL ID, document ID, tenant ID, chunk index, content, to vector string embedding, private string to vector string, float app vector, return arrays to string vector. Step 13. Full ingestion service. At service public class document ingestion service. Private final text extraction service, text extraction service. Private final text chunking service, chunking service. Private final embedding service, embedding service. Private final vector repository, vector repository. Public document ingestion service. Text extraction service, text extraction service. Text chunking service, chunking service. Embedding service, embedding service. Vector repository, vector repository. This text extraction service equals text extraction service. This chunking service equals chunking service. This embedding service equals embedding service. This vector repository equals vector repository. Public void process document, UUID, document ID, string text equals text extraction service dot extract text, path of document path. List string chunks equals chunking service dot chunk text. For int I equals 0, I equals chunks dot size, I plus plus. String chunk equals chunks dot get I. Float embedding equals embedding service create embedding chunk. Vector repository dot save chunk, UUID dot random UUID, document ID tenant 001, I chunk embedding. Step 14. Build semantic search API. Endpoint. Get API, search, query, password, reset, controller. REST controller at request mapping /API/search, public class search controller. Private final vector search service, vector search service. Public search controller, vector search service, vector search service. This vector search service equals vector search service. Get mapping public list search result response. Search at request param string query. Return vector search service dot search query. Add step 15 search service at service public class vector search service. Private final embedding service embedding service. Private final vector repository vector repository. Public vector search service embedding service embedding service. Vector repository vector repository. This embedding service is embedding service. This vector repository is vector repository. Public list search result response, search string query. Float query embedding equals embedding service dot create embedding query. Return vector repository search similar query embedding tenant 001 5. Step 16. Vector similarity query. Using pgvector cosine distance. Public list, search result response, search similar, float query embedding, string tenant ID, int top k. String SQL equals select document ID, content, 1 minus embedding exex vector as score from document chunks where tenant ID equals order by embedding exex vector limit string vector equals to vector string query embedding return jdbc template dot query sql new objects vector tenant ID vector top k rs rownum new search result response rs.getObject document ID uuid.class rs.getString content rs.getDouble score. Result example. To reset your password, go to account settings, ... If you cannot access your account, ... Step 17. Add metadata filtering, search request, get, API, search query, refund policy, and category, billing. Query. Select document ID, content, from document chunks where tenant ID equals a and category equals a. Order by embedding xxx.vector, limit 5. Useful filters. Check tenant ID, check category, check document type, check created by, check created date, check language, check access level. Step 18. Add RAG answer generation. Semantic search only returns documents. RAG generates an answer. Flow. User question. Search vector DB. Retrieve relevant chunks. Build prompt with context. Call LLM. Return final answer. Example endpoint. Post API -chat. Request. How do I reset my password? Response. You can reset your password from account settings by selecting Forgot Password. Sources. accountguide.pdf, loginfaq.pdf. Step 19. RAG service design. @service, public class, RAG service. Private, final, vector search service, vector search service. Private, final, chat client, chat client. Public RAG service. Vector search service, vector search service. Chat client, chat client. This vector search service equals vector search service. This chat client equals chat client. Public RAG response. Ask string question. List search result response context equals vector search service dot search question. String prompt equals build prompt question context. String answer equals chat client dot prompt dot user prompt call content. Return new RAG response answer context. Private string build prompt string question list search result response context. Return answer the question using only the context below. Context. Question. %s. Formatted context question. Step 20. Multi-tenant design. In enterprise systems, each organization has private documents. Example. Tenant A means can search only tenant A documents. Tenant B means can search only tenant B documents. Architecture. JWT. Token. Extract tenant ID. Apply tenant ID filter. Vector search. Example. String tenant ID equals security context get tenant ID. Vector repository.search similar. Query embedding tenant ID 5. Very important. Never search without tenant ID filter in SaaS systems. Step 21. Security design. Security requirements. JWT authentication, role-based authorization, tenant isolation, document-level access control, API key protection, audit logging, encryption, secure file upload. Bad design. Front end means vector database. Good design. Front end means Spring Boot API means vector database. Reason. Check backend validates user. Check backend applies filters. Check backend hides credentials. Check backend audits access. Step 22. Error handling. Common errors. Capital. File upload failure. Unsupported file type. Text extraction failure. Embedding API failure. Vector DB timeout. Kafka retry failure. No search results. Permission denied. Example response. Error code, vector search failed. Message, unable to complete search request. Best practices. Use global exception handler. Retry transient failures. Use dead letter queue. Validate file size. Validate file type. Log correlation ID. Step 23. Performance optimization. Common optimization techniques. Use vector indexes. Limit top K. Use metadata filters. Cache frequent queries. Batch embeddings. Async ingestion. Avoid huge chunks. Use connection pooling. Monitor slow queries. Scale embedding workers. Example. Redis cache. Check query cache. Vector search only if cache miss. Step 24. Batch ingestion. For large document imports. 10,000 documents. Spring batch job. Read documents. Extract text. Chunk text. Generate embeddings. Store vectors. Spring batch is useful for retries. Chunk processing. Restartability. Large data loads. Scheduled ingestion. Step 25. Real-time ingestion. For real-time content. New article created. Article service. Kafka event. Embedding consumer. Vector DB insert. Example. Event type. Article created. Article ID 501. Tenant ID org 101. Content. Spring Boot security article. Useful for check blogs, product catalogs, support articles, social media feeds, knowledge bases. Step 26. Monitoring. Monitor. Upload success rate, ingestion failures, embedding latency, vector search latency, no result queries, low score queries, top K relevance, vector DB storage, Kafka lag, API cost. Useful tools. Spring Boot Actuator, Spring Boot Prometheus, Grafana, OpenTelemetry, ELK Stack, Datadog, CloudWatch. Step 27. Testing strategy. Testing should include check unit tests, check integration tests, repository tests, API tests, embedding mock tests, vector search tests, security tests. Example unit test. At test void should return search results. List search result response. Results equals vector search service.search password reset. Assert false. Results.is empty. For embedding models, use mocks in unit tests. Use real embeddings in integration tests. Step 28. Evaluation strategy. Search quality must be evaluated. Important metrics. Metric meaning precision, correct results returned, recall, correct results found, latency, search response time, top K accuracy, correct answer appears in top results, relevance score, how useful result is. Example evaluation. Query. How do I change password? Expected document. Password reset guide.pdf. Actual top result. Login troubleshooting.pdf. Action. Improve chunking or hybrid search. Step 29. Deployment architecture. Docker-based deployment. React container, Spring Boot container, PostgreSQL plus pgvector container, Redis container, Kafka container, embedding worker container. Kubernetes deployment. Ingress. Spring Boot API pods. Vector DB service. PostgreSQL. Kafka. Worker pods. Production best practices. Check. Separate ingestion workers. Configure autoscaling. Use secrets manager. Enable health checks. Set resource limits. Monitor vector DB latency. Backup metadata database. Step 30. Production checklist. Before production. Check. Authentication enabled. Check. Tenant filtering enforced. Check. File size limits configured. Check. Virus scan for uploads. Check. Embedding API key secured. Check. Vector index created. Check. Monitoring enabled. Check. Retry logic added. Check. Dead letter queue configured. Check. Logs include correlation ID. Check. Source document stored. Model version tracked. Strategy ready. Check. Load testing completed. API design summary. Upload document post/API document/upload. Response: Document ID 101. Status: Processing. Check document status. Get API Documents 101 status. Response: Document ID 101. Status: Ready. Semantic search. Get API search. Query password reset.
Response:
Reset your password from account settings. Ask question post API chat. Request: How do I reset my password? Response: You can reset your password from account settings. Real-world example: customer support knowledge base scenario. A company wants to reduce support tickets. Users ask questions like, how do I update billing? Why was my payment declined? How do I reset my password? Can I cancel my subscription? The AI knowledge base searches internal documents and answers using RAG. System architecture customer. React Chat UI. Spring Boot Chat API. Vector search service. Vector database. LLM answer generator. Response with sources. Backend services service. Responsibility. Document service. Upload and manage files. Ingestion service. Extract, chunk, embed. Vector search service. Semantic search. Service generate AI answer. Auth service JWT and tenant access. Audit service track user activity. Data flow example 1. Admin uploads refund policy.pdf. 2. Spring Boot stores file metadata. 3. Kafka event is published. Worker extracts text 5. Text is split into chunks 6. Embeddings are generated 7. Vectors are stored 8. User asks refund question 9. Query embedding is generated 10. Vector DB returns matching chunks 11. LLM generates answer using chunks 12. Spring Boot returns answer with sources. Common beginner mistakes. 1. Storing whole documents as one vector. Bad. 1 PDF equals 1 vector. Better. 1 PDF equals many meaningful chunks 2. No tenant filtering. Dangerous for SaaS systems. Always filter by tenant ID 3. No source references. Users need to know where answers came from. Always return source file, page number if possible, chunk reference, document link. 4. Using VectorDB as main database. VectorDB is not a full replacement for PostgreSQL. Better design. PostgreSQL equals business metadata. VectorDB equals semantic search. 5. Poor chunking. Bad chunks create bad results. Good chunks should be, comma, not too large, not too small. Include overlap, preserve context.
6. Ignoring re-embedding.
When embedding model changes, old vectors may need to be regenerated. Store. Embedding model version 7. No monitoring. Without monitoring, you cannot know search quality, latency, failure rate, cost. Best practices. Keep VectorDB behind Spring Boot API. Store metadata in PostgreSQL. Store embeddings in VectorDB. Use tenant ID filtering. Use async ingestion. Split documents into chunks. Add chunk overlap. Store source references. Use vector indexes. Use hybrid search when needed. Use retries for embedding failures. Use dead letter queues. Cache common queries. Monitor latency and relevance. Evaluate top case search quality. Secure API keys. Version embedding models. Keep original documents. Interview questions 1. Why use a vector database with Spring Boot? To build semantic search, recommendation, RAG, and AI-powered backend systems where data is searched by meaning instead of exact keywords. 2. What is the role of Spring Boot in vector search architecture? Spring Boot handles APIs, authentication, authorization, ingestion orchestration, metadata management, and communication with the vector database. 3. What is document chunking? Document chunking is splitting large documents into smaller sections before generating embeddings. 4. Why store metadata with vectors? Metadata helps filter search results by tenant, category, document type, date, user, or permissions. 5. Why use Kafka in vector ingestion? Kafka enables asynchronous processing, retry handling, scalability, and separation between upload and embedding generation. 6. What is RAG? RAG stands for Retrieval Augmented Generation. It retrieves relevant context from a vector database and uses it to generate an answer with an LLM. 7. How do you secure vector search in SaaS? Use JWT authentication, role-based authorization, tenant ID filtering, document-level permissions, and backend controlled search APIs. 8. Does vector database replace PostgreSQL? No. PostgreSQL is used for transactional and metadata data. Vector databases are used for similarity search. 9. How do you improve vector search quality? Use better chunking, better embeddings, metadata filtering, hybrid search, re-ranking, score thresholds, and evaluation datasets. 10. How do you handle embedding API failures? Use retries, backoff, Kafka retry topics, dead letter queues, error status, and reprocessing jobs. Vector Database Case Study Roadmap Beginner Stage. Learn Vector Database Basics, Vector Embeddings, Semantic Search, pgvector, Spring Boot REST API. Build Simple Semantic Search API. Intermediate Stage. Learn COP, Document Upload, Text Extraction, Chunking, Vector Indexing, Metadata Filtering, Spring AI. Build AI Document Search System, Advanced Stage. Learn Kafka Ingestion, Multi-tenancy, RAG, Observability, Evaluation, Kubernetes Deployment. Build Enterprise AI Knowledge Base. Final summary. A vector database case study with Spring Boot shows how backend developers can build intelligent AI-powered search systems. Important concepts include JEC embeddings, JEC document chunking, JEC vector similarity search, JEC metadata filtering, JEC Spring Boot APIs, JEC PostgreSQL metadata, JEC pgvector, JEC Kafka ingestion, JEC RAG, tenant security, monitoring, production deployment. Backend developers already understand REST APIs, databases, security, microservices, event-driven systems, deployment. This makes vector database integration easier to learn. Key idea. Spring Boot provides the backend architecture, while the vector database provides meaning-based search for AI-powered applications.